Hello everyone, welcome to our presentation. Today I present a AutoML and meta learning based research paper. My research paper name is the meta learning of automatic neural network channel pruning. This paper is mainly published on IEEE CVF conference on computer vision and the pattern recognition in 2019. I am Imrus. Now I present this paper. First of all, we see the outline of this paper. First, the introduction, background model, problem and the focusing method, algorithm, experiment and the conclusion. First of all, the introduction. Actually, the channel pruning is the applied of reduce huge memory consumption and the high computational complexity of the convolutional neural network. They have proposed a pruning net that can general weight of the all candidates prune network structures such they can search good performance structure by just evaluating their accuracy on the validation data, which is highly efficient. A typical pruning approach contains three stages. The three stages are the training a large over parameterized network, pruning the less important weights of the channel, and the fitting or the networking the network. Recently, some automate style words automatically prune the channels in the iterative modes. So they propose the method of pruning net. To train the pruning net, they use the stochastic structure sampling. Next, the background model. We see the model, one is training and another is searching. The pruning net generates two weights of the pruning network with the corresponding network encoding vector, which is the number of channels in the each layer. By stochastically feeding in the different network encoding vector, the pruning net gradually learns to generate weights for the various pruning structure. After the training, they serve a good performance prune network by the evolutionary search method, which can flexibly import in various containers such as computation, FLOPS, or the hardware latency. Now we see the problem and the focusing of method. Basically, by the directly sourcing the best prune network via determining the channel for each layer or each stage, they can prune the channel in the shortcut without extra effort, which is the CellDROM address in the previous channel pruning solution. They proposed a name for the proposed method at the meta pruning, the contribution and the focus. Basically, in this paper, they focus on the meta pruning or the channel pruning compared to conventional pruning method and compared to other AutoML method. Meta pruning can easily enforce the content in the source of the desired structures. So basically they focus this thing, and then we see the algorithm section. In their algorithm, meta learning approach of automatically pruning channels in deep neural network, that prune network could meet various containers easily. So we see the pruning net training, and here the basically the channel pruning is the non-trivial because the layer wise dependency in the channel such the pruning on the channel may the significantly influence of the following layer in the return and drag the over accuracy. So to training the pure net, they have proposed the stochastic structure sampling in the training phase, and the network encoding vector is the generated by the randomly chosen of the number of the channel in the each layer of each iteration. So we can say that with the difference network encoding, dependency prune network are constructed and the corresponding weights are the property of the prune net. And then we see here is the model. Basically the model is based on the pruning network, and the generate weight matrix is the crop of the mass, the number of the input of the output channel. So this is the stochastics training method of the pruning net, and at each iteration they have randomized a network encoding vector, and the pruning net generate the weight taking the vectorized input. The pruning network is constructed with the respect to the vector, and the erode the weights gradient by the pruning net to match the input and output channel in the pruning network. Then we see the second algorithm, the pruning network search. After the pruning net is trained, they have obtained accuracy of each potential pruning network by input the network encoding into the pruning net and the generating corresponding weight and doing the evaluation of the validation data. In the evolutionary algorithm used in the meta pruning, each prune net is encoding a vector of the channel and number of each layer. Name the genes of the prune networks, and under the hand contains we first actually the first random select the number of the genes and obtain the accuracy of the corresponding prune network by doing the evolution. Then the top K genes with the highest accuracy are selected for the generating of the new genes with the mutation of the crossover, and the mutation is carried out by the changing of the proportion of the elements in the gene randomly, and the crossover means we actually they random the recombination of recombine the genes in the two pairs genes and generate of the offspring. And we see there is the model basically, and the first image and the second image. In the first image, the network structure of the pruning net connected with the pruning network, and the pruning net and the pruning network are jointly with the input of the network encoding vector as well as the mini branch of image. And the second image actually says the receive and the crop operation on the weight matrix generated by the pruning net block. So here is the algorithm section, and then we actually see the experiment section. Basically they have demonstrated the effectiveness of this proposed pruning net method with the steps. Basically the four steps: one is the explain the experiment setting and introduce, and the compare result with the uniform pruning baseline as well as the state of art channel pruning method, and visualize the prune network, obtain the meta pruning, and evolution studies in the carry out of the evolutionary effect of the weight production. And first we see the experiment setting. Basically in the meta pruning method consists of the two stages. In the first stage, the pruning net is trained from the source with the stochastic structure sampling, which takes 1 by 4 epochs as training a network normally. And the second one is they use the evolutionary search algorithm to find out the best prune network. For the training process is both stages they are used the standard data augmentation strategy as to the process of input image. They have adopted the same training in the experiment on the mobile net and the training of the RSNet. And after obtaining the base prune network, the prune network is trained from the starts on the original training dataset and the evolutionary test dataset. And then we see the meta pruning on the mobile net and the RSNet. Basically they are too famous, and mobile net v1 is a network without shortcut. To construct the corresponding prune net, they have pruning net blocks equally the number of the convolution layer in the mobile net v1, and the each pruning net blocks is the composite of two fully connected layer. So we say other formula, basically C denoted the channel and L noted the layer, and LL noted the previous layer, and O means the output of the original pruning output. And second is the mobile net v2. In the mobile net v2 is stage starts with the block machine in the demonstration between two stages. If the stage consists of the more than one block, The following blocks is the stage will the contain a shortcut adding the input feature map. With the input feature map, and those input and output channel is the stage should be identical as shown as the figure. So we see in here the figure, the feature map, the weight, actually the different layer, and then we see the RSNet. As a network with shortcut, RSNet is the similar network structure with the mobile net v2, and the only differs the typical convention layer, middle layer, and the downsampling block of the block of each stage. And we see the next experimental stage, the comparison of the state of art, and they have compared the method with the uniform pruning baseline traditional pruning method as well as the state of art channel pruning method. So in the first table we see the mobile net v1, the input vector of the pruning net is the number of channel, is each layer the vector is dedicated into channel into the layer. And this table compare with the top one accuracy for the meta pruning method with the uniform baseline on the mobile net v1. So we see the meta pruning accuracy for the flops chaining process, and the second table actually mention this is a top one accuracy of the meta pruning method with the uniform baseline on the mobile net v2, and mobile net v2 only reports the accuracy with 585 million and the 300 million flops. So they apply the uniform pruning methods on the mobile net v2 to obtain the baseline of the accuracy. And in the third table, the table compares the top one accuracy of the meta pruning uniform baseline and the state of art channel pruning method. So we see here the meta pruning accuracy is more than higher than the others. And the fourth table, basically this table compare the top one accuracy of the meta pruning method with the other state of art AutoML based method. So basically this is focused the AutoML based method, and we see the meta pruning accuracy is more higher than the others method. So basically here the comparison state of the art. And then we see the figure. Basically this is the visualization of this graph, and the pruning network structure. Mobile net v1, we observe the significant peaks in the pruning network every time when there is downsampling operation in the figure 1. So we see the figure 1, here is the significant peak and the prune network. And the figure 2, basically the middle channel will provide the pruning less when the corresponding block is responsible for sharing the feature map size. So in the figure map, this is the block index and the corresponding block and the feature map size basically. And then we see in the mobile net v2, each stage starts with the block net bottleneck block with the differ input and output channel of the flowing several repeat blocknet blocks, and the bottleneck block with the same input and output channel are the connected with the shortcut in the figure 3 basically. Then the figure 4, they compare the between performance of pruning net and the weight prediction, and that without weight prediction influence the accuracy of several uniform prune net of the mobile net v1. So we see the comparison basically in figure 4 with weight prediction and without weight prediction for the uniform pruning ratio. And the last, actually we can say they compare the performance between the pruning net with the without weight prediction. Here they have select the channel number, and with the uniformly pruning each layer a ratio ranging from the 0.25 to 1, and evaluate the accuracy with the weight generated by these two pruning net. And figure 4 already we show, we can see the figure 4 shows the pruning net without weight prediction, and actually actually the ACB is 10% lower than the accuracy. So basically in this work they have present the meta pruning of the channel pruning with the following advantages. It achieves much higher accuracy than the uninformed pruning baseline as well as other state of art channel pruning method, both the traditional and the automobile based. It can flexible optimize with the respect of different constraints without the introducing of extra hyperter, and then the ResNet like the architecture can be efficiently handled, and the whole pipeline is highly efficient. So here is the main conclusion of this paper. So thank you very much to connect with us. So thank you everyone.